chemistry, we're now moving on to our first lesson actually in the subject of chemistry, and this is on elements and the basic atom. So an element is pure matter that cannot be divided into simpler substances. An atom is the smallest piece of an element. When you cut an element as far as you can, you will have an atom of that element. There are about 90 naturally occurring elements, plus about another 28 that were created by scientists in labs. All matter in the universe is made of these 90 elements. Below are 5 naturally occurring elements: carbon, gold, neon, uranium, and mercury. And we'll talk about these in more detail as this course goes on. In about 400 BC, a Greek named Democritus developed the idea that there was a smallest piece of matter that could not be further subdivided. The Greeks would have debates about this. Of course, they had no way to experiment, but some of them said that you could take a piece of gold and cut it in half, at least theoretically. If you could get a knife small enough, cut it in half forever. Whereas others said, such as Democritus, said no, you're going to eventually get to a smallest piece of gold that you cannot cut in half. So the Greek word atomos means indivisible, that cannot be divided. The smallest piece of an element is called an atom. Just as the 26 letters of the English language can be arranged to make millions of words, the 90 elements can be arranged and combined to make millions of different substances called compounds. A compound is a substance containing 2 or more elements. There are up to 50 million chemical substances, and I'm tempted to change that and say, who knows? I've heard even in the billions, but the point is, those 90 elements can be combined in almost countless number of ways, to create all of these different chemical substances or chemical compounds. Water, consisting of the elements hydrogen and oxygen, is the most common compound on Earth. The periodic table is a list of all the elements in the universe. The periodic table is the centerpiece of the study of chemistry. And part of what you'll learn in this class very soon is why does it have this slightly unusual shape? What do those different colors mean? What are the different parts of the periodic table? But you'll realize that there's a lot of reasoning behind the shape of the periodic table. Dmitri Mendeleev is credited with creating the periodic table. He did much of his work by laying out cards while riding trains around Russia. Electrical force is the single most important factor in all of chemistry. The key point about electrical force is positive attracts negative and negative attracts positive. Positive repels, pushes away positive, and negative repels, pushes away negative. And these facts are at the basis of almost everything we'll talk about every day throughout the rest of this course. An atom is the smallest piece of an element there is. If you cut an atom of gold or iron in half, you will no longer have gold or iron. An atom consists of 3 components, those are parts. First are protons, those have a positive charge. Next, neutrons, those have no charge. And third are electrons, those have a negative charge. And all 3 of those components were discovered just within about the last 100 years. The neutron was only discovered about 90 years ago. So here's the basic structure of an atom. So it has a center called a nucleus. Now if you've taken biology, you learned about the nucleus of a cell, and it was a part of the cell which was in a pouch somewhere in the middle of the cell, and it contained the DNA by which the cell could replicate itself. The nucleus doesn't have a pouch around it, but it's simply the center of the atom. Orbitals, also called shells, these are energy levels where electrons move around the nucleus. Inside the nucleus are two of the three particles. Protons, positively charged particles in the nucleus, and neutrons are neutral or no charge particles in the nucleus. So the electrons fly around the nucleus. They're attracted to the nucleus by the protons. Remember, positive attracts negative. So that's what keeps the electrons just from flying away out into space. Scientists still cannot totally understand why the electrons don't just get sucked into the nucleus, but they don't. So why doesn't the electron just simply, it's attracted to the proton, why doesn't it just simply fall into the nucleus? And the answer is that's still not completely known. Electrons, those are the negatively charged particles that circle the nucleus. Now, you become familiar with this word, you're going to hear it almost every day, valence. A valence orbital is the outer orbital of an atom. Because helium has only one orbital, this is the valence orbital. Valence electrons are the electrons in the valence orbital. It is the valence electrons that form chemical bonds to be discussed later. So ultimately what chemistry studies is why do atoms of one element why are they attracted to the atoms either of the same element or of different elements to cause chemical bonds? Because those chemical bonds are what create new compounds and new substances. And it's the outside electrons, those valence electrons, that do this connection between one atom and another. So they're extremely important in chemistry. So a proton is the positively charged part of an atom. You don't need to understand what positive means other than that it's the opposite of negative. A proton has a mass, and you really don't need to know this number, but occasionally we might run into some calculations with it, of 1.67262 times 10 to the negative 22nd kilograms. That's about 1,836 times more massive than an electron. A proton has a charge of, and there it is, and we'll talk about what a coulomb is. That's the letter C, but it's 1.602 times 10 to the minus 19th, very small number, which is a number we will rarely use. Most commonly, what we will use is we will simply assign a charge of +1 to a proton. That's the charge on a proton, and a mass of 1 atomic mass unit to a proton. So for the most part, an atomic mass unit is designed as the mass of a proton and also a neutron, which has about the same mass. Protons contain the strong nuclear force which holds them together in the nucleus against the repulsion of the electromagnetic force. So we just said that positive should repel positive. It does repel positive. So protons should push each other apart. So why doesn't the nucleus of an atom just fly apart? It can have a lot of protons in it. The answer is the strong nuclear force holds them together. An electron is the negatively charged part of an atom. An electron has a negative charge equal and opposite to that of a proton, which is 1.602 times 10 to the minus 19th, except we say it's a negative charge. An electron has a mass, and there you can see the number, I won't read it, but it's 10 to the minus 31. So that's about 1,836th as massive as a proton. In other words, it's very tiny compared to a proton. An electron moves outside of the nucleus in specific energy levels called orbitals. Okay. A neutron is the part of an atom that has no charge. In the simplest sense, a neutron is made up of a proton and an electron. That's kind of a simplification, but that's basically what it is, which neutralize each other. The neutron has a mass, and there you see the number. This is slightly more than the mass of a proton, but not exactly equal to the mass of a proton plus an electron added together, and we won't get into that discussion. It's not that important. So in chemistry, we assign a charge of 0 because a neutron has no charge. And we say it also has a mass of 1, the same as a proton. So for our purposes, a proton and a neutron both have the same mass, and we simply say that mass is 1 atomic mass unit. Neutrons contain the strong nuclear force which holds protons together in the nucleus against the electromagnetic force. So they don't repel the protons because they don't have a charge to them, but they do have the strong nuclear force. So what they do is they stabilize the nucleus. They help out in holding the protons together. In about 1800, English chemist John Dalton developed his atomic theory describing atoms and how they combine to form compounds. So first, we'll just read through them. There's 4 parts to this. All elements are composed of indivisible atoms. 2, atoms of the same element are identical. Atoms of one element are different from those of another element. 3, atoms of different elements can combine in whole number ratios to form compounds. That's a combination of 2 or more elements. And 4, chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. So let's look at this in a little more detail and see where Dalton was right and where he might have been wrong. The following are some notes concerning Dalton's 4 principles. First, that all elements are composed of indivisible atoms. Dalton developed these 4 postulates 100 years before the discovery of protons, neutrons, and electrons, which we already discussed. Dalton is correct that atoms cannot be divided into simpler substances. Number 2, atoms of the same element are identical. Atoms of one element are different from those of another element. Dalton did not know of the concept of ions and isotopes, and that will be discussed in the next few lessons. Atoms of different elements can combine in whole number ratios to form compounds, combinations of 2 or elements. This is completely correct. An atom cannot be divided. That's why it's possible to have H2O, which you know as water, but it's not possible to have H1.5O. So it has to be a whole number of atoms that combine. 4, chemical reactions are when atoms join, separate, or are rearranged. Atoms of one element cannot be changed into another element. The first sentence is completely correct, and in fact it's the definition of chemistry. Rearrangements of atoms is the definition of chemistry. Atoms can, however, be changed into other elements. This occurs during nuclear reactions, which involves changes in the nucleus. So here we see the periodic table, and you see some divisions. These are really listed down at the bottom, but you may have noticed them. And it shows the different sections of the periodic table. You will be expected to know these and have these memorized. But there's really 2 broad classes. These are a little more specific. There's 2 broad classes that we really talk about a lot. Number 1 is metals, and that would be everything on roughly the left 2/3 of the periodic table. That would include the alkali metals way over on the left, the alkaline earth metals. That valley in the middle are called the transition metals. Then you have other metals, or down at the bottom you'll see that on the legend down there they call them basic metals. The metalloids are kind of a border between metals and non-metals, so they're not metals technically. Then number 2, you have the non-metals. Non-metals are everything you see there in orange, plus the halogens. Halogens are nonmetals, and so are noble gases, but we generally refer to halogens as halogens and noble gases as such because they have special properties. So those would be the nonmetals. It's just really the far right-hand side of the periodic table. And then the metalloids, as I just said, form a border between the metals and the nonmetals. So we'll see how metals and nonmetals react with each other and together. So the representative elements are the group A elements. That's the first 2 columns, alkali metals and alkaline earth metals, and the last 6 columns where you see it says 3A, 4A, 5A, 6A, 7A, 8A. Those are called representative group elements. Those are have special important role in chemical compounds. Chemical reactions create new substances by rearranging atoms into new compounds through a chemical reaction. So, for example, 2 hydrogen molecules, that's H2, plus 1 oxygen molecule produces 2 water molecules, H2O. Water is comprised of 2 atoms of hydrogen and 1 atom of oxygen. A chemical change occurs when the atoms combine to form a structure called a molecule. In this case, it can form other structures, but in this case it's called a molecule. Because water is made up of more than 1 different kind of element, it is referred to as a compound. So there we see it. There you see 2 hydrogen molecules, so the two atoms stuck together make one molecule. You have two hydrogen molecules. You have one oxygen molecule. Again, two oxygen atoms put together form an oxygen molecule. Now, H2 and O2 are not compounds because they only consist of one element. They're called elemental molecules. But then they break apart, and how they do that is something we'll talk about in this class, and they reform to form molecules and compounds that have one oxygen and two hydrogens. And you get two of those. So you notice that the number of oxygens on the left side of the arrow equals the same as the number on the right side. The number of hydrogens on the left side of the arrow equals the same number of hydrogens on the right side. Chemical reactions create new substances by rearranging atoms into new compounds through a chemical reaction. So 2H2 plus O2 gives you 2H2O. Water is made of two hydrogen atoms and one oxygen atom to form a new substance called water, H2O. The way water reacts with your body is totally different than the way pure oxygen and pure hydrogen react with your body. So if you drink water, it has a certain impact on your body. It reacts with your body. If you were to drink liquid hydrogen or liquid oxygen, it would kill you. So they have different properties. You can't just, say that what's on the left side is equal to what's on the right side. It's a different substance. Physical changes determine whether a particular substance is solid, liquid, or gas. These are called states or phases of matter. There are three states of matter: solid, liquid, and gas. Solids, molecules are held firmly together. In the case of water, we call this ice. Liquids, molecules touch but can move around one another, so liquid water splashes around. And gas, molecules have enough energy to separate from each other and move upward against gravity. So the molecules or the particles, the atoms, are separated from each other. The term gas in chemistry has nothing to do with the stuff that people put in their cars at gas stations. That's called gasoline. It's a chemical compound that's used to power cars. This gas simply means that you have molecules of any type that are unattached from each other and they can move freely. A nuclear reaction is one where the number of protons and neutrons changes. So this is a change in the nucleus. Number of protons changes. Elements are defined by the number of protons. I'm going to say that a second time. Elements are defined by the number of protons, not the number of neutrons or electrons. So if a proton is added or removed from an oxygen atom, the atom will no longer be oxygen. If it were added, it would become fluorine, and if it were taken away, it would become nitrogen. So it would change what the substance is by changing the protons. Number of neutrons change. The number of neutrons in two atoms of the same element can be different. These are called isotopes. Carbon has 6 protons. It must have 6 protons, otherwise it's not carbon. Most carbon atoms also have 6 neutrons, but some have 7 neutrons or 8 neutrons. The different atoms are isotopes of carbon. Alright, and that takes care of this lesson, introducing you to the atom, and we will be studying that throughout the rest of this course.